Welcome back. We are looking at tree diagrams under probability, and we have a question on the board. The question is coming from the Examinations Council and 2020 paper 2 school certificate, and it reads, a bag contains 7 red and 3 white identical balls. 2 balls are taken from the bag at random, one after the other, without replacement. Draw a tree diagram to show all possible outcomes. Find the probability of taking at least one white ball. Okay, so the question is testing our capacity in generating tree diagrams when we are given conditions like the way we are given. So we are told in this particular bag there are 7 red and 3 white identical balls. So before we draw the tree diagram, we need to find the individual probabilities, that of taking a red ball and that of taking a white ball. And the way we are going to generate these probabilities, we know probabilities are given as numbers between 0 and 1. So we are talking about basically proper fractions. So we are going to have a denominator here and here, and we are also going to have a numerator here and here. Now, the way we are going to find the denominator is the total number of items under discussion. So the items under discussion in our case, we are talking about identical balls. So we are talking about identical balls, 7 red and 3 white. So the denominator we are saying will be the total of items under discussion. So we shall say 7 plus 3 and we shall get a 10. So this will be the denominator for both probabilities, that of picking on a red ball and that of picking a white ball. Okay, coming to the numerators for these individual probabilities, we know when we come to the probability of taking a red ball, we need to find out how many of these 10 balls are red. So how many of these 10 balls are red? We are told that 7 are red. So the 7 is what we are going to put here. Coming to the white balls, again, what we need to put here are the total number of white balls out of the 10 balls. So we are told white balls are 3. Okay, so these are the individual probabilities that we are going to use in the construction of our tree diagram. So I'm going to put them here. Probability red, probability white. Okay, so having found the individual probabilities, we can now look at how to draw a tree diagram. And this is a Roman numeral 1, and we are going to start our tree diagram like this. And we know our tree diagram is going to have 2 branches. Our tree diagram is going to have 2 branches, and it will have 2 branches. There's this branch and the other branch. Now, what determines the number of branches are the different kinds of items that are under discussion. The different items, the number of the different items that are under discussion. So the different items under discussion here the bows. Now these bows are in two types. So the different types of the items under discussion determines the number of branches that our tree diagram is going to have. So you can see there are red balls and there are also white balls. So because there are red balls and white balls, two colors, therefore our tree diagram is supposed to start with two branches. And we are going to follow this order. We are told that 7 are red and 3 are white. So one of the branches will represent red, the other one will represent white. Okay. And the individual probabilities for this first set of branches will be the probabilities that we found out. So the probability of picking on red ball, 7 out of 10. That of picking on a white ball, 3 out of 10. Okay, so the first set of branches is done, and we can now look at the second set of branches. So the way we produce the second set of branches, we know from each one of the branches we have to produce another set of branches. From each one we have to produce another set. Okay, so we have from the white branch we have this set, and from the red branch we have this other set, and we should maintain the same arrangement as in the first set of branches. So we started with red, then white. So even here, red, then white, and red, then white. Okay. And we are going to also write down the individual probabilities of each one of the second set of probabilities. Okay. Now, first of all, we are going to start by writing down the denominator for the second set. We need to know how to write the denominator. Now, we are told that two balls are taken from the bag at random. Two balls are taken from the bag at random. At random means there is no order in the there's no biasness in the picking. That's what we mean by at random. There's no biasness in the picking. That's what is meant by at random. And two balls are taken from the bag at random, one after the other. One after the other is very important because we need to know how the picking is being done. Now, this particular picking is being done one after the other. The two balls were not taken at one go. They were not taken at one go, like getting the two of them at one go. No. The two balls were taken one after the other. This one is taken, put aside, and going back, taking the other ball and putting it aside. So the picking was being done one after the other. This one is taken, put aside, the other one is taken and put aside. So that is how the picking was being done. And because of the way the picking was being done, one after the other, so it means the first ball was picked out of 10. The first ball was picked out of 10. That's why the first set of branches represents the first picking. The first set of branches represents where the first picking is going to be done from. Okay, so the first ball was picked out of 10. So this one was picked from the 10 and put aside. So initially, before the first picking, the balls were 10. Now one was picked and put aside. So they were 10 initially. Now after picking one, it means what remains there in the bag is 10 minus 1, which is 9. And we are told that once that one was picked, it was not replaced. Because we are told that without replacement. This one is very important. This phrase is very important because it affects the denominator in the second set of branches. Without replacement, meaning that the first ball that was picked for good, taken for good. It was never replaced. So because in the first, initially there were 10, now this ball that was picked, this one ball that was picked, we know it was one ball that was picked in the first picking because we are told that the balls were being picked one after the other. So the first ball that was picked was never replaced. So meaning that what remained in the bag there was 9. So 9 balls remained in the bag because the first ball was not replaced. So because the first ball was not replaced, therefore the denominator will reduce by 1. So the denominator in the second set reduces by 1 because actually the first ball that was picked was never replaced. Okay, let's move on. Okay, now coming to the enumerators of the second set, we need to know that this set of branches, which is being generated from the red branch, as soon as we go to the red branch, and produce this set, what we are communicating is that that first ball that was picked was a red one. That is the communication that is there. As soon as we go to the red branch and produce these two branches, what we mean is that, or what we are communicating is that the first ball that was picked in the first picking was actually a red ball. So since the first ball that was picked was a red ball, because we are going to the red branch, and implying that what was picked was a red ball. So since what was picked was a red ball and it was never replaced, and the red balls initially were 7, then that one was picked from the 7 and never replaced, so meaning that the red balls reduced by 1. And because we have gone to the red ball and implying that what was picked was a red ball, so it means the white balls remained the way they were in the first picking. Okay. The same applies to the white branch here. If we go to the white branch, what we are communicating is that the ball that was picked in the first picking was a white ball. The ball that was picked in the first picking was a white ball, and because it was a white ball, the whites are going to reduce from 3 to 2. Yes. So the whites are going to reduce from 3 to 2 because actually that ball that was picked, that one ball that was picked was a white ball. So as soon as we go to the white branch and produce this set of branches, what we are telling ourselves is that what was picked was a white ball, and because the white balls were 3, so they reduced by 1, and here we have a 2. And because it was a white ball that was picked, it means the red balls remain intact. 7, the way they were in the first picking. Okay, so this is actually how the probabilities are generated. The first set represents the first picking, and the second set represents the second picking. Okay, so now coming to the possible outcomes. This is red, and from red we have these branches. So red, when we go here we have red. Okay, we have red. When we go to here we have red, white. We have white here, and when we come here we have red, so we have white, red. We have white here, and when we come here we have white, white. Okay, so these are the possible outcomes, and just as the question asked us to find, we were told to draw a tree diagram and to show all possible outcomes. So the possible outcomes are red, 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 white, white, red, and white, white. Okay? So continuing, when we look at part 2 of the question, we are told to find the probability of taking at least one white ball. So under here, we are told to find the probability of taking at least one white. At least one white. So, at least one white. We have to be careful with this word, at least. We need to know what it means for us to correctly handle this question. So, when we come across at least, what it means is that what is there and more. That's what at least means. What is there and more. So when we say at least white, what we are communicating is that wherever we have one white or more, one white or more, that's what at least means. It means one white or more. One white or more. So where we have one white or more, we are looking at red, white, also white, red, and also white, white. Here there is one white, here there is one white, here there are two whites. All these are falling under at least. At least means what is there and more. So when we say at least one white, we mean where we have one white and where we have more than one white. Okay, so now coming to the calculations, we know when we say red, white, it means we are multiplying here. So red, white, so red, we have 7 over 10 multiplied by 3 over 9. Whatever we shall get, we shall add 2. White, 3 of 10. White, red, 7 over 9 plus white, white, 3 of 10 and 2 of 9. 2 over 9. Okay. Okay. So now, multiplying, we have, we are going to say 7 by 3. We know how fractions are multiplied. So we say 7 by 3. We multiply the numerators. 7 by 3 we get 21. Out of 10 by 9 we get 90. Plus 3 by 7 again 21. Out of 10 by 9 we get 90. Plus 3 by 2 we get 6. Out of 10 by 9 we get 90. So this is getting to, we need a common denominator. Common denominator is 90. And since the denominator is the same, you can just go on and add the numerators. 21 plus 21, this is 42, plus 40 plus 6, this will give us 48. Okay, so 48, and now we need to reduce this one to lowest term, and we know there is a number that goes into 48 and 90, and that number is 8 into, or 6 into, that number is 6 into 48 is 8, and 6 into 90 is 15. So actually what we are getting is 8 over 15. And when we reach here, there is no common factor, so we can just conclude to say, therefore, the probability of taking at least one white ball is 8 out of 15. So, we need to pay particular attention to these particular phrases, one after the other, what it means. And when we have phrases like without replacement and words like at least, these are very key in calculating these probabilities. And we know without replacement affects the denominator in the second set of branches. And also, one after the other tells you and I that the picking is being done one after the other. The two balls are not picked all together at one go, but they are picked one by one. So, thank you very much for your attention. Subscribe to my channel, Matete Chansa, and like my videos. Also invite your colleagues, watch my videos. Thank you very much for your attention.